Hey guys, this is video 4 on bounds. So we're going to be looking at calculations and how we can use our bounds knowledge to do calculations which combine all of the things that we've looked at above. So the stuff you see here is where we apply all the knowledge of bounds that we have. So length, area, volume, and things like that. So here's an example question you would get with bounds. You're working out in this case, the greatest and smallest possible area of this rectangle. Now you're told that the width is 30 meters correct to one significant figure, and the height is 4 meters correct to the nearest meter. So all questions with bounds, you can just draw a table of values of all the bounds that you might need to use here. So we can see the width, the upper bound, well, a half the degree of accuracy, so is one significant figure. The first significant figure is 3. The place value is 10 because it's the tens column. So half of 10 is 5. So the upper bound is 35. And the lower bound is, I take away 5, so I get 25. And then I do the same thing for the height. The upper bound for the height says correct to the nearest meter, so I half that, so I get half a meter. So upper bound is 4.5. And lower bound is 3.5. Now, the greatest possible area, you can just use common sense for this. You know, it's just going to be the upper bound times the upper bound of the width times the upper bound of the height. And then for the smallest possible area, it's going to be the lower bound of the width times the lower bound of the height. So I've actually worked it out here. This is how you might also lay out your working, and with the subscript representing upper bound or lower bound. Now, this was the most straightforward type of calculation you can get, where you're just multiplying two numbers. You're finding the biggest possible answer and the smallest possible answer. There's loads of other potential questions you could get where you have to, for example, add and subtract and multiply. So we're going to look at that now.